Welcome to Mustard Seed International E-Learning Program. Hey Raj, do you remember the joke today in cafeteria?
Oh yeah, Nilu. I just couldn't stop laughing. And Nilu, your laugh, it just scared too many in the cafeteria.
Yeah, it was like groundbreaking. When you say groundbreaking, I'm reminded of earthquakes.
Yeah, Padma. Can you enlighten us on this groundbreaking earthquake?
Sure, here we go. After completing this module, you will be able to understand the concept of an earthquake, explain the types of seismic waves, describe the types of earthquakes, explain how to track an earthquake, understand the research and tracking in India. This session covers definition of an earthquake, seismic waves, tracking the earthquake, and research and tracking in India. An earthquake is the shaking or strong vibrations on the ground caused as a result of internal forces and disturbance in the earth's crust or upper part of the mantle. The terms associated with earthquake are focus or hypocenter or seismic focus, epicenter, seismic waves, fault and fault scarp. Focus, hypocenter, seismic focus mean the same, which means the place of origin of an earthquake inside the earth. Epicenter, a point on the earth's surface vertically above the focus. Maximum damage is caused at the epicenter. Fault. Fault is a planar fracture or discontinuity in a volume of rock across which there has been a significant displacement as a result of rock mass movement. Fault scarp. Fault scarp is the feature on the surface of Earth that looks like a step caused by slip on the fault. There are four types of earthquakes: tectonic earthquake, volcanic earthquake, collapse earthquake, explosion earthquake. Tectonic earthquake occurs when Earth's crust breaks due to geological forces on rocks and adjoining plates that causes physical and chemical changes. Volcanic earthquake resulted from tectonic forces which occur in conjunction with volcanic activity. Collapse earthquakes. They are small earthquakes occur in underground caverns and mines that are caused by seismic waves produced from the explosion of rock on the surface. And explosion earthquake resulted due to the detonation of a nuclear or chemical device. Seismic waves. Seismic waves are the waves of energy that are generated by an earthquake that travel within the earth or along its surface. Seismic waves are two types. They are body waves and surface waves. Body waves are two types: primary and secondary waves. And surface waves are also two types: love waves and Rayleigh waves. Body waves, they are generated due to the release of energy at the focus and move in all directions, traveling through the body of the earth. They travel only through the interior of the earth. Body waves are faster than surface waves, and hence they are the first to be detected on seismograph. Primary waves or P waves. These are the waves that move the fastest and are the first to reach during an earthquake. They are similar to sound waves, that is, they are longitudinal waves in which the particle movement is in the same direction of wave propagation with a push and pull effect. They travel through solid, liquid, and gaseous material. Velocity of P waves in solids is more, less in liquids, and lesser in gases. They create density differences in the earth material, leading to stretching and squeezing.
Secondary waves or S waves?
They arrive at the surface with some time lag after primary waves. They are transverse waves in which direction of particle movement and wave propagation are at right angle to each other, hence called as transverse or distortional waves. They can pass only through solid material. Surface waves. When the body waves interact with surface rocks, a new set of waves is generated called as surface waves. These waves move along the Earth's surface. They create crusts and troughs in the material through which they pass. These waves are also called as long period waves. They are low frequency waves, they have long wavelength, and they have transverse vibrations. They develop in the immediate neighborhood of the epicenter. They cause displacement of rocks and hence the collapse of structures occurs. These waves are the most destructive, recorded last on the seismograph. Long waves, this kind of surface waves, causes horizontal shifting of the earth during an earthquake. They are much slower than body waves but are faster than Rayleigh. They exist only in the presence of semi-finite medium overlain by an upper finite thickness. Confined to the surface of the crust, long waves produce entirely horizontal motion. These waves follow an elliptical motion. A Rayleigh wave rolls along the ground just like a wave rolls across a lake or an ocean. Because it rolls, it moves the ground up and down and side to side in the same direction that the wave is moving. Most of the shaking felt from an earthquake is due to the Rayleigh wave, which can be much larger than the other waves.
Well, but how do you know about it and measure it?
I'm scared, but excited too.
Sure thing, here it is. Seismograph is an instrument to measure the vibrations of an earthquake. It tells us about the strength and the speed of seismic waves. Seismogram. Seismogram is a recording made on the seismograph. It tells us how strong the earthquake was, where it began, and how long it lasted. Magnitude and intensity are two ways in which a quake's strength is expressed. Magnitude is a measure that depends on the seismic energy radiated by the quake recorded on the seismographs. Intensity is a measure that depends on the damage caused by the quake. It does not have a mathematical basis but is based on observed effects. To measure the magnitude of a quake, Richter scale is used. It is not a physical measurement, but a logarithmic scale based on the recordings of seismographs and instruments which automatically detect and record the intensity, direction, and duration of a movement on the ground. The intensity of an earthquake can be measured by modified Mercalli intensity scale. To measure the intensity of an earthquake, the modified Mercalli intensity scale is used. Modified Mercalli scale. Not felt. Felt by persons at rest on upper floors or favorably placed. Felt indoors. Vibration like passing of light trucks. Vibration like passing of heavy trucks. Felt outdoors. Small unstable objects displaced or upset. Felt by all. Furniture moved. Weak plaster. Masonry cracks. Difficult to stand. Damage to masonry chimneys. Partial collapse of masonry. Frame houses moved. Masonry seriously damaged or destroyed. Many buildings and bridges destroyed. Rails bent greatly. Pipelines severely damaged. Damage nearly total.
It was informative. What are the organizations which are carrying out research and tracking in India?
Sure thing. Here it is. Indian Meteorological Department (IMD) is responsible for monitoring seismic activity in and around the country. The first seismological observatory of India was set up in Calcutta in 1898. It is responsible to quickly estimate the earthquake parameters immediately on occurrence of an earthquake and share the information to all the user agencies, including concerned state and central government agencies responsible for the relief and rehabilitation measures. National Center for Ocean Information Service (INCOIS). The information relating to undersea earthquakes, which are capable of generating tsunamis on Indian coastal regions, are shared with the Indian National Center for Ocean Information Service. INCOIS evaluates the tsunami-genic potential and issues necessary warnings, alerts as per the situation. National Center of Seismology came into being in August 2014. It deals with upgradation of seismic monitoring network, microzonation of 30 cities, in-house research on various seismological aspects like GPS, active fault mapping, seismic wave analysis, tomography, earth precursory studies, etc. IMD maintains a countrywide national seismological network consisting more than 80 seismological stations across the country. Deep borehole investigations in Koyna-Varna region. The Koyna Dam is located in Maharashtra. Seismologists and other scientists from the National Geophysical Research Institute plan to establish a deep borehole observatory in the seismically active intraplate fault zone in Koyna-Varna region. Continuous monitoring of this borehole at 7 km depth would enable measurement of physical and mechanical properties of rocks, hydrology, temperature and other parameters in the near field of earthquakes before, during and after their occurrence.
Is there any big project to investigate earthquake?
Sure, here we go. Scientists are able to learn about Earth's internal structure by measuring the arrival of seismic waves at different stations around the world. For example, we know that Earth's outer core is liquid because S waves are not able to pass through it. When an earthquake occurs, there is a shadow zone on the opposite side of the Earth where no S waves arrive. Similarly, we know that the Earth has a solid inner core because some P waves are reflected off the boundary between the inner core and the outer core. By measuring the time it takes for seismic waves to travel along many different paths through the Earth, we can figure out the velocity structure of the Earth. Abrupt changes in velocity with depth correspond to boundaries between different layers of the Earth composed of different materials. I hope you have understood the basic concepts of an earthquake now. At the end of this module, you have learned that an earthquake is the shaking or strong vibrations on the ground caused as a result of internal forces and disturbance in the Earth's crust or upper part of the mantle. Focus: the place of origin of an earthquake inside the Earth. Epicenter: point on Earth's surface vertically above the focus. Seismograph: the instrument to measure the vibrations of an earthquake. Magnitude and intensity to measure the earthquake. Research in India. Indian Meteorological Department, IMD, Indian National Center for Ocean Information Service, INCOIS, National Center of Seismology, NCS.